Hi guys, as you can tell from my voice, I'm still kind of sick, so I'm going to make you a video for Residuals Day 2. So if you go into your packet, you'll find this worksheet that you're seeing on your screen, and you can kind of read that it's talking about the temperature in Celsius, right? That's going to be over on the bottom, along with the number of ice creams sold over here on the left-hand side. All right, so it says for part A, draw the line of best fit. Now, because, again, I've said this before, we can all kind of draw different lines, I'm going to tell you exactly which points that I want you to use. Okay, so over here, I'd like you to use the point 2050, which is right here. And up top, I'm going to have you use the point 2570, which is right here. And you should get that line. All right, so now we're gonna, as we have been before and we've been practicing for a while now, we need to find the equation of the line. All right, so the first thing we need is the slope, which is the change of y over the change of x. And again, I'm gonna use the two ordered pairs that I told you to use. So if I subtract the y's, 70 minus 50, and on the bottom I'm going to subtract the x's, which is going to be 25 minus 20, and I end up getting 20 over 5, which is 4. So I now have my slope. Now all I need, in addition to slope, is the point slope equation, which looks like this. All right, so I'm going to use the slope that I just found out along with this ordered pair. So here we go. Y is equal to 50 plus the m times x minus the x. So I'm going to distribute and combine some like terms. So 4x minus 80. These two terms are what's like, and this is going to be the equation we're going to use for the rest of this worksheet. It's going to be 4x minus 30. Okay, so now if you read the next question, it says find the point that's furthest away from your line. Okay, now I'm looking at this thing and I see two that appear to be furthest from my line. I think it's this one and this one. So it really doesn't matter which one we pick. I'm going to use this one. Oh, maybe not. Hold on. I'm going to use that one. All right, and if I count, I can see that I'm about 1, 2, 3, 4, 5 points away. Okay, so it's asking for the residual. Okay, you learned the formula for residuals yesterday. Residual is equal to actual minus prediction. Okay, so if it's asking me to find the residual, I need the actual point, which is the green one right here, 55, minus my prediction, which is this orange one down here, which is 50. And you get a residual of 5. Okay, so question D is asking if you were selling ice cream treats, would you rather have a positive or a negative residual? Okay, so our answer above is a positive residual. Okay, and can you see that that means that up here, the actual number sold is much higher than what I predicted. So I definitely want a positive residual because it means that the number sold is higher than predicted. Okay, so now I'm on question E. Okay, so it says use your equation. So let me write my equation one more time. Y is equal to 4x minus 30 to predict how many ice cream treats would be sold on a day that's 27 degrees. Okay, so notice over here, this is the x-axis. Temperature is on the x-axis. So that means I need to put 27 right in there. So it'll look like this. Y is equal to 4 times 27 minus 30. Okay, 4 times 27 is 107 minus 30. And if I subtract, I believe I get 77. All right, so let me scoot this up. Okay, and you'll have to turn your page. All right, So different people will come up with different lines for the data. This will give them different predictions, okay? So we've talked about this before, about how every one of us could draw a different line of best fit, but some are better than others. So this question is asking, okay, so which of these is the better one? And it's this one. This is definitely the better line of best fit. Okay, and if you look, you can see that the residuals, right, the distance away from the line, are smaller. These that I've drawn in blue are a heck of a lot smaller than these that I'm trying to draw in red. See how far away these are from the line? This is a bad line of best fit. Okay, so I'm gonna let you fill in this question. I did not fill it in on purpose. I want you guys to fill it in. Okay, so every single line of best fit has a number associated with it. And we're gonna figure out for the line that we drew what that particular number is, okay? It's called the sum of the squares of the residuals. All right, so this data that you're looking at right here is the data that was on the front, okay? What you're gonna have to do is figure out what, based on our line, right? And if you remember, our equation of the line was y equals 4x minus 30. You are gonna have to fill in this column by plugging in these numbers. Okay, so pause the video and fill in those numbers. And it should look something like that. All right, so then, now keep in mind, those are our predictions. Okay, and over here, these are actual numbers. Okay, so here, for this column right here, where we're asked to find the residuals, we have to do actual minus prediction. Okay, so again, pause the video so that you can try to calculate those residuals. And it should look something like that. All right, and then the very last column, it says residual squared. So you're gonna take the numbers that are in this column and just multiply them by themselves. So pause the video and see if you can fill in that column. And it should look like this. All right, and so then the very last thing you have to do is to find the sum of the last column. Sum means you're going to add those up. All right, so again, it might need a calculator, but if you add those up, you should get 89. Okay, so if we did this exact little table for, let's say, this line up here, that number would be a lot higher because it's a really bad line of best fit. But ours is pretty good. All right, so hopefully that makes sense. If you've got questions, feel free to shoot me an email or hold on to your questions and I will answer them as soon as I can get back.